3 of the Unit 6 exam review. Questions 17, 18, 19, and 20 are all similar in the sense that they are all proportion problems. We're going to go ahead and same way by using the cross product, which allows us to multiply across the equal sign and set up an equivalent statement. We're going to make sure on number 19 and 20, though, that we're going to distribute the 8 to the 3x minus 10 and distribute the 10 to the x plus 1. Biggest mistake students make is not putting this in parentheses when we cross product. So let's get started. Number 17 first. The equivalent equation is 3 times x is equal to 9 times 8. We're going to multiply this out. 3x equals 72. We'll divide by 3. Gives us x equals 24. Similar on number 18, we're going to cross product. Gives us 15 times x is equal to 30 times 7. We'll multiply this out. Gives us 15x equals 210. We'll divide by 15. Gives us x equals 14. Questions number 19 and 20. Once again, we want to make sure we're distributing appropriately. So when I do my cross product, 5 times 4 is equal to 10 times the quantity, x plus 1. Making sure we put those parentheses in so we know to distribute the 10. I will distribute the 10 and multiply by 10, giving us x is equal to 1. In question number 20, again, we'll cross product. 20 times 2 is equal to 8 times the quantity, 3x minus 10. We'll distribute the 8 and multiply this out, which gives us 40 equals 24x minus 80. I'll add 80 to both sides. Gives us 120 equals 24x. We'll divide both sides by 24, giving us an answer of x is equal to 5. Once again, all solved by cross product since they're all straight proportions, and we simplify. Next set of questions involves the arithmetic and geometric. We're going to find the arithmetic and geometric mean of both. Focusing on question number 21, the formulas for the geometric mean. For the arithmetic mean, we take the sum divided by the total. For the geometric mean, we take the product to the nth. See what that looks like. We have 2 plus 27, 72 over 2 for the sum over the total for the arithmetic mean. For the geometric, we take 2 times 72, the product taken to the second root or the square root. The answers are 37 and 12. 37 for the arithmetic mean, 12 for the geometric mean. Again, arithmetic, sum over total, geometric, product to the nth root. Let's take a look at 22. Two numbers here, 5 and 45. So we'll be dividing by 2 and taking to the square root again. We have 5 plus 45 over 2 versus 5 times 45 underneath the square root. These answers are giving us answers of 25 for the arithmetic mean and 15 for the geometric mean. Question 23, once again, we have two numbers, so we're going to be dividing by 2 and taking the square root. 9 plus 49 over 2 versus 9 times 49 underneath the square root. These answers are 29 for the arithmetic mean and 21 for the geometric mean. Now, all three of those examples, we were given 2 terms. We're now going to go ahead and progress to ones where we're given 3 and then finally 4 terms. Question number 24, 7, 8, and 49. 3 terms means we'll be dividing by 3 and taking the cube root, which gives us 7 plus 8 plus 49 over 3, and 7 times 8 times 49 to the third root. One note on this, how I can get the third root, we can go to math, and then the fifth option gives you x root, so you can type in any number that you want. You could also use math 4 for the cube root, but math 5 gives you the ability to write any number you want for the root. The answers to this are approximately 21.3, that's from 64 divided by 3, and the geometric mean is 14. Question number 25. Again, 3 numbers, so we're going to divide by 3 and take the cube root. 8 plus 11 plus 121 over 3, and 8 times 11 times 121 underneath the cube root. These answers gives us 46.7 approximately for the arithmetic and 22 for the geometric mean. Question 26, 4 terms, so we'll be dividing by 4 and taking the fourth root. We'll be dividing by 4 here as we take the fourth root. Once again, math option 5 allows you to put in the fourth root for this, giving us our x is 10 for the arithmetic mean and 6 for the geometric mean. Got to know the formulas for the exam. We should know how to do the average, the arithmetic mean. However, we have to remember the formula for the geometric mean and remember how to access the multiple roots on the calculator. Last 2 questions on this page are application problems. We talked about 3 classic types of application problems in class. This is an example of one of them, which is in fact the sun creating shadows. We should see I actually drew in the sun in question 28, and it creates a couple shadows down here on the bottom. The shadow for the flag is the hole, and then here's the shadow of the flag from the lamp pole. We have the shadow of the tree and the shadow of the person. We talk about 3 types: shadow, overlapping your multiple measures. That's like to find measure of a rock or trying to measure of a canyon. And then reflection problems where we're looking into a puddle, we're looking into a mirror. We should review our notes on all 3 of those. As 2 of them will probably show up on the examples of these shadows. How tall the girl is, and here we're trying to figure out how tall the flagpole is. Okay, problem number 27. We should see that we actually have 2 triangles here, where we know the 2 legs, and we're trying to figure out one of the shorter legs. I can set up a proportion between the heights 15 and x and 24 and 8, which are the shadows. 15 over x and 24 over 8. We can solve this by cross product, giving us 15 times 8 is equal to 24 times x. We're going to go ahead and multiply this, giving us 120 equals 24, divided by 24, giving us x is equal to 5. However, we are going to go ahead and put this into context of our problem, which is that x is equal to 5 feet and the girl meaning is 5 feet tall. Okay, question 28. We're given the shadow of the flagpole. We're given dimensions in our diagram, not in our diagram, but actually in the word problem. CE is 80. We see that the shadow of the lamp, the 12-foot lamp is 30 feet. So we're going to put those onto the diagram. So the full distance is 80, meaning, and the shadow of the lamp pole, which is 12 feet tall, is 30 feet. We now see that we have 2 different triangles. We have 12 and 30, and then we have our unknown value, which we're trying to go ahead and find, and 80. We're going to set up a proportion from this. X over 12, height over height, is equal to 80 over 30, shadow over shadow. We're going to go ahead and cross product this. Cross product again, which gives us 30x equals 12 times 80. We're going to go ahead and multiply this out, giving us 30x equals 960. We're going to divide both sides by 30, which gives us that x is equal to 32, or 32 feet, which means the flagpole is 32 feet long. There will be a few applications again on the test. Will be 2 of the 3 of our problems we went over in class. Thanks.